Hello, I'm Stephen Waterman, and today I'm here to talk to you about Svelte. I don't expect you to have heard of it before, so don't worry if you haven't, and I don't even expect you to have any web development experience. It's a complete beginner-level introduction, but hopefully you can kind of see the benefits, nevertheless, even if you've never used any web frameworks before. What we're going to be talking about specifically today is, well, first of all, who are you? We kind of covered that. Stephen Waterman. Yeah, it's fine, but more detail. And I'll kind of talk a bit more about why I care about Svelte and why you can trust my opinion. Then we want to know, who is Svelte? Or, in fact, what is Svelte? It's probably going to be. Then we're going to jump straight into a live demo, and we're going to program a fairly basic, but also complex in terms of interaction, website. It's not going to look the best, but it'll be, under the hood, it'll do a fair bit. We're then going to cover a few of my favourite features in Svelte, bits that we didn't get to cover in the live demo, because sadly I just don't have time. My first attempt at recording this took over an hour just for the live demo, so quite a lot of stuff had to get cut out of there. But then we're going to go home, or rather you're going to go to the after school club, you're going to chat with people, and yeah, networking. Let's jump straight in and let's talk about who I am. First of all, yeah, I'm Stephen Waterman. Should have got that from the first screen. I'm a developer at Scotlogic, which apparently, according to Google Images, looks like this. Sometimes, yeah. I write a lot of blog posts. If you look really closely, I'm sure you can see some Svelte ones in there. Back in the day, I was very much a back-end person. In fact, I was a back-end goblin, was the phrasing that I chose to go with here. I was a back-end goblin, just was not a fan of front-end. It was all confusing, it was too fluffy, too presentation-y. And I think that was because a lot of my initial experience with front-end was jQuery and just vanilla JavaScript. And it was so fiddly, and it was so imperative. And I mean, I'm a very big fan of like functional programming, and at least functional styles. And web development was not that. And then, in January this year, which seems like ages ago, and at the same time not very much time at all, but I started working on a side project of mine called MuseTree. And MuseTree is it works off MuseNet, which is OpenAI's MIDI generator using AI. It's like deep learning. And I didn't like their interface, so I made my own. And having heard a tech talk about Svelte, probably one very similar to this, although a bit shorter, I decided to jump straight in and just try out Svelte. And I loved it. And this is now a launched app. You can try it online. It's like musetree.stephenwaterman.uk. Have a play around. It's pretty good fun and fairly addictive. But yeah, it struck me how simple it was and how I didn't have to worry about any of that imperativeness thanks to using Svelte. And this is a complex application. I think this is probably one of the larger applications that's been written with Svelte. But it really turned me. Like, it convinced me that perhaps backend wasn't the be-all and end-all, and actually I could kind of enjoy a bit of front-end development, especially with kind of Svelte and TypeScript, and the things that mean that I don't have to worry about all of that. And so I'm here today to convince you the same. So you will leave here, hopefully, agreeing with me. Fingers crossed. I've introduced myself, but let's introduce what Svelte is. I've kind of mentioned that, you know, it's a front-end web framework. It is for making the front end of your website. Yeah, in that sense, it's similar to React, Vue, Angular. I guess it's similar to jQuery, if you really want to go that far. But it's competing in a busy space. And why, I guess, should you care? Well, it's compiled. And that's probably strange for a front-end web framework in a world where we have JavaScript and interpreters, that we would choose to write JavaScript which then gets compiled. But that actually that is kind of the core of why it's so much better. And we'll come back to this. But let's take a quick aside and ask the four other W questions. Who made it was Rich Harris of Rollup. I don't know if you've used Rollup. It's a bit like Webpack. It's pretty good. And then it's open source, and yeah, lots of other people started contributing. This is the past month, and Rich Harris is not there. He's still very active on issues and pull requests and things, but he's not really writing code for it anymore. It's taken on a life of its own, the same way that kind of React has, although React is Facebook. This is a little bit different. Svelte isn't backed by a big company or anything. It's a bit more of a traditional open source project in that sense. Next question, when was it made? Well, the very first sighting, first alpha, first version released, was November 2016. It then lasted a long time. And, no, same month, they released 1.0.0. So I'm honestly not sure whether it was just that 1.0.0 was very simple, or whether the first alpha was very complex, or whether Rich Harris is just an absolute god among men and programmed all of Svelte in less than a month. An actually long time later, 2.5 years or so, Svelte 3 was released. And that's probably the big milestone. That was when it started to pick up a bit more momentum, I think. Because it started to be a little bit more production ready. And we'll come back to kind of, should you use this in production later on? But the answer's, yeah, kinda. Why should I care about Svelte? What makes it special? What is its selling point? Well, it's fast. And yeah, it's fast in both senses of the word. And this comes back to the title of the talk, I guess. It makes your websites fast. It makes your websites small, meaning that they load faster, because both of those are because you've got no runtime libraries. And it also makes you faster, because there is basically no boilerplate. And how did they do that? Well, no runtime libraries. And it's because it's compiled to custom JavaScript. As in, there is no large, 10,000 line library that you are loading and is running on every bit of your app and is trying to make it very general. It looks at your app and it will hard code the JavaScript relevant for your app. You'll see what this means a little bit later, but basically it means that it is as good as if you had handwritten it, or near. It tries to get as good. So yeah, it's got a hard-coded dependency graph. And essentially that means that it knows which variables affect which bits of the page, and it knows that because it's hard-coded in the JavaScript, because it works that out at compile time and then puts it in the output of JavaScript, rather than trying to constantly figure that out every time it tries to change anything, every time you load the page, as you would with a general runtime library. And then because it's got that dependency graph, it knows exactly what is changing, and therefore it can just surgically update the DOM. There's no virtual DOM like React has, where it has to track every single node, because to make up for inadequacies in, browser support, it is just straight up edit the text in this node, add a node here, and it does that without needing to then first recalculate everything. So hopefully you understand a bit more about Svelte now. Let's just jump straight in and see a live demo where we are going to create an app from scratch using Svelte, and I'll talk you through a lot of the basic concepts as we go. To start off with a new Svelte app, you want to just type npx dgit svelte.js/template, and then give it the name that you want to save it in. So we'll call it demo. And that's going to just clone the Svelte template into this folder called demo. If we then move into that folder and install the dependencies for the demo, we can then run it, and we do npm run dev, and essentially that just sets up hot reloading and all of those things that make development really nice. Here's a web browser I opened earlier, but if you go to localhost 5000, you can see the basic kind of page that you get. That's the same as you would get with create React app. It's doing the same thing. If we go back into VS Code, we can then see that this app.svelte file has been added to the source folder. I mean, it was added when we cloned the repository. It hasn't been added by us running it. That is the component which is being displayed on the page. We don't want any of this currently because we're going to remake this and, pretend that none of that, pretend you didn't see anything. What we've got here is an empty Svelte component, and it produces an empty page. The Svelte component itself has 3 parts to it. There is the first part, which usually goes at the bottom of the file, which is just any HTML that you want. Hello, I am HTML. HTML! Exclamation mark. There we go, look. That's easy enough, and you can do anything you want. You can put buttons in there. Let's just do hello. There we go. So you can just put any HTML you want in there. Yeah, great. We've got a component-based HTML web framework. but we only know the HTML so far. You can probably guess what the next bit is, which is styling. So let's add some styling into this page. So to do that, we use the style tag, just like that. And then in here, we can write any CSS we want. If we want to make, you know, the button text like 1,000,000 times bigger, we can say, what is it, like font size? I'm not great at CSS. This is right at the start when I said that I didn't really never liked front end. It was too presentational. Here we go. There we go. There's our button. Font size 100 pixels, and it's a button. And if we want to use classes, then we can. We can say like header, and we can say background color is going to be red. All headers should be red, obviously. We haven't used that class yet, so we'll just put that in the div. And we say class equals header. There we go. And now our div is red. So that's pretty useful. We've got CSS there. And this CSS is local to the component. So everything that you put in here is just going to be local to this component. If we have another component somewhere and we say class equals header, then it's not going to have this this red background. Let's tidy this up a little bit, because at this rate, I'm not going to end up showing you what I want to show you. The app that I want to make is a kind of light switch board. So let's just make a div called with the class light. And then let's make this class here into light. What I want to say is that by default, lights are grey. They have a height of about 50 pixels. And they have a width also about 50 pixels. Gonna work? Yeah, there we go. There's a grey square. Lights tend to be round, so we'll put a border radius on it of 50%. And it should be round. Yeah, and then let's actually add a border to it. We'll give it a just border. I want to give it 1 pixel, solid black. The classic. Cool. So yeah, there is a circle which has been styled with our style. We can do that. And that's how styles work. The final part of these components is the JavaScript. And to add JavaScript, you just use a script tag right at the top of the component. And again, you can put a script tag in every component. It's restricted to just that one component. And we can put any JavaScript we want to run in here. Console.log. Hello. Oh, hello. I'm going to keep that. I warned you about the typing struggles. There you go. And you can see that it says hello. Anything that we put inside this script tag is going to get run exactly once when the component gets created. The next step would be actually how do we interface between the JavaScript and the page. Obviously, you could do something horrendous. You could put like document.querySelector and just use Svelte but not actually use it. But realistically, what you want to just say is like we'll call it like light on equals true. And then down here, we can just straight up say like light on, colon, and then put it in curly brackets, light on. And in this way, Svelte is almost like it's like a templating language or a macro-based language. We can put anything we want in here, but as soon as there's some curly brackets, anything inside of those curly brackets will get evaluated based on the script up here, and then the result will just get plunked right into that, right into the page, like that. Cool. Just displaying whether or not the light is on the page isn't very nice, so let's actually just add another class, which is called light on, and what it's going to do is set the background color to yellow. Background color. So now we've got that light on, and it's going to put that in there. Well, sorry, light on. So it's currently not going to do anything because light on isn't getting used. We could just use this light on variable in a ternary to kind of generate a string for the class, but actually Svelte's already got us covered with that. We can say class light on equals light on. And that's a kind of shorthand to say, when the light on variable is true, add this class to the div. And you can see now it's yellow, and if we set this to false and wait for it to re-render, now it's off. this is kind of a consistent theme with Svelte, is that they've just thought of the common things you would want to do, and they made it really easy. And actually, in this case, because the class name and the variable name are the same, we don't even need that equals. We can just say class colon light on, and it'll just work. Because, yeah, why make that complicated, you know? I'm going to leave it like that for now. It's up to you, it's personal preference. Honestly, I'm doing it because it makes our lives easier in the future. Let's get rid of that console.log as well, and we'll get rid of this. What we've got now is a nice little light, which we can choose whether or not it should be on. There we go. And we'll set it to false. But wouldn't it be nicer if there was actually a way to toggle the light from within the page without having to just recompile the page? Because it is, every time the page re-renders on the right there, it is actually recompiling. So let's say that we have this toggle function, and it says that light on equals not light on. And then we want that to be called whenever we click on this light. So if we want to do event handlers in Svelte, again, it's easy. On click equals toggle. And you could use an arrow function in there, that works as well, but it tends to get a bit long and a bit messy. So now we click on that, it goes yellow. We've, like, yeah, that's it. That works. If you've come from other web frameworks, that might seem a little bit strange. In that light on is just a normal variable up here. When we've said that class colon light on equals that, in a lot of other frameworks, that wouldn't mean whenever the variable changes, add or remove this. It would just mean, you know, set it as a parameter on creation of that div. But not in Svelte. Svelte's whole thing is about reactivity. So it's the analogy that I like to make is comparing mathematicians and programmers. A programmer might say x is equal to y plus 2 and mean, please set x to the current value of y plus 2. And when a mathematician says x equals y plus 2, they mean it's always 2 more than y. Although that might be identical, go with it, go with the analogy. The other side of that is that programmers are happy to say x equals x plus 2, but mathematicians are horrified. Svelte is more like a mathematician in that regard. If I say x is equal to y plus 2, with some conditions, if I say x is equal to y plus 2, then Svelte is going to always update x whenever y updates. We'll see a bit more about that and how you actually need to, it's kind of opt-in, but we'll talk about it. So yeah, but for now, we are updating that light on, and it's updating the div. Just straight up. Like, what more do you want, frankly? And look how simple that is. There's nothing telling it to re-render. There's nothing kind of complex going on. We just straight up say that, you know, this div should have the light on class based on whether or not this light on variable is true or false, and we can just change it and it works. So, frankly, that's pretty good. And what's even better is that it's lightning fast. When we toggle this, it's then hard-coded that any changes. So it's hard-coded that when we call toggle, it should then It should then go to everywhere that this light on variable is used, and then surgically add this class to this div. Like, it doesn't even like delete and recreate the div. It just sort of goes in and it adds the class. And that's so fast. Let's try and add a second light and see how that looks. And here you'll see why I didn't want to use the shorthand in that class. What do you call it? Class? I don't know. Conditional class? I think this is called like conditional class shorthand. So we say light on 1, light on 2, and we'll need to use those in here. Cool. And then, yeah, so light on should actually be light on 1. Then you should be toggle 1. And we'll copy that and make light on 2 and toggle 2. There we go. We've now got 2 lights and they're individually controllable. Yeah, perfect. You can probably see where this is going. It's not pretty, is it? All of that code that we just had to write, and this kind of these numbered toggles is not the prettiest thing. So I think it's probably time for us to add a child component and show off how you can use these kind of styled components. Well, we just create a new Svelte file like we did, and you know I'm going to copy this one and use it as a base. Rather than having 2 toggles, we only need 1. and we're going to rename that light on variable to just light on. Basically just going back to how we had this before, aren't we? We still have the light, still have light on, and then class colon light on can now just use that shorthand again, like that. In app.svelte, we now don't need any of this stuff. We don't need any of this style. And we could get rid of these script and style tags, but I'm going to need them later on, so I may as well keep them. You don't need them in a component necessarily. I have quite a few components in my project that are just HTML and CSS because it's nice kind of self-contained styled components for you to use. But here we go, the light. And it's automatically imported that for me. I can definitely recommend the Svelte extension for VS Code. It makes that kind of thing much easier. And now we want two lights. Let's get rid of those divs. So now, just as we had before, you see there's no difference because why would there be? We've just pulled it out into its own component and then brought it in twice like that. But they're individually controllable. So each instance of this light has its own light on variable, it has its own toggle function, and all of that. They're all individually controllable, and we're bringing them into that app component. However, wouldn't it be nice if we had some way to control the lights from this app component? Let's just say like let initial state is going to be equal to false. I want some way to be able to choose whether or not the light should be on or off by default. Well, that's actually really easy. All you need to do is, instead of saying let light on, say export let light on. And then you can get rid of the equals if you want. You can have that, you can make it a required property by getting rid of the equals, or you make it an optional property by leaving it in there. I'm going to leave it optional. And then we set the initial state. All we need to do is, as you would with any other, HTML tag, we're going to say light on is going to be equal to initial state. Here we see one of the rough edges of the VS Code integration is that it really likes importing methods that it shouldn't when you just want it to autocomplete based on those variables. Support is getting a lot better though. It's been very impressive as I've been watching like the added TypeScript support, which I wrote a blog on, by the way. Hint, hint. Yeah, but if we have our initial state variable, we set it to false, they're false. We set it to true, now they're true. This is a one-way binding. It's essentially write only. So this app component, the parent component, can set the light on value in the child, but the child can't then change that variable and pass it back up to the parent. So just to illustrate that first point, if I do like set interval and say that I want it to, initial state equals not initial state, just toggle that, and I want it to do it every second, then they're now flashing on and off. And that's because the parent component has power over the child components, and it's changing this value, so these get re-rendered. Or realistically, they don't get re-rendered. It comes in here and says, okay, this has now changed, follows through what should change. Because we don't do full component re-rendering, really, ever. But, as I've said, it doesn't work the other way. And that should be kind of obvious, actually, because we've bound one value to both of these. But if I just say, like, set interval, and just say, once a second, I want it to go console.log initial state. And get rid of these methods that it keeps trying to import when I don't want it to. Then what we should see in the console is that I've spelt it wrong. Yep. Oh, I've spelt it wrong there, not there. Oh, that's good. Good job, Steve. Word true, because they are on. And if I turn them off, then it continues to log the word true. And that's because that initial state variable hasn't actually changed. If we do want a two-way data binding, then we have to use the bind keyword rather than just saying light on equals. And the bind keyword is straight up one of the best bits about Svelte. So let's just say let light1 on, and again, because it's binding, we do need to have two separate variables, otherwise they're going to be forced to stay in sync. And by default, I want to say that its value is going to be initial state. Let light2 on. By default, it is the value of initial state. Stop importing init. Oh my god. Right, okay. Instead of just saying we're going to set that, we're going to bind it. And we're not going to bind it to initial state, we're going to bind it to light 1 on and light 2 on. Okay, so again, those still work as you would expect, but the big difference here is that if we say set interval console.log light 1 on, light 2 on every second, you say true, 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 but if I change one of them, now it's true, false. So we've got two-way data binding there. The change when we press the button, when we click on the light, that happens in the light component, it updates its variable, but our light 1 on variable is bound to the light on variable inside of that one. Binding works even if you're not just binding to a specific variable. We could even say let lights on is going to be equal to, let's say, false, true, like that. And then in here we can just say bind light on to lights on element 0, and bind light on to lights on element 1. So you can actually bind them to elements of an array or even keys on an object, which means that it's completely trivial to build up complex objects. Like if you have a form and you're building up a JSON response, you can just bind each bit, like each input, to a key on the object that you're about to send, like the request object, the DTO, which is crazy and like so simple because you don't have to worry about it. And so yeah, that is still working, except it's actually editing the values in there. If we go back to that set interval and we say we want to console.log the lights on value, and I want that to happen every second, not as fast as I just said there, please. Yeah, false, true, change that, now it's true, true. We're editing an array with our subcomponents, with two-way data bindings, and it's all magical. I've talked a lot about reactivity in this so far, and actually one of the things that makes Svelte amazing, one of the things that we haven't used at all, even though it's a core feature, is this $: syntax. What that means is that anything on this line that we write, if we write console.log lights on, not loop guard, log, there we go, lights on. If we write console.log lights on, but we use this $: syntax, Svelte will run this line whenever any of the dependencies in here change. In practice, that means whenever lights on gets updated, this line will run. So we had our console.log before, but it was in a set interval. We don't need that. Svelte has reactivity. As soon as I click any of these, you can see on the console, it detects that they've updated and it runs the console log. Where this gets even more powerful is where you can use the $: syntax to assign values to variables. Let's say light on count, yeah, and it's just going to be equal to lights on filter to those that are currently on. So just use the identity function to count the number of trues, like that. And let's display that on the page. 1 light is on, 2 lights are on. And this variable will get recomputed anytime the underlying array changes. So let's add a little display to say how many of the lights are turned on. Lights on is going to be the light on count. Now we've got a little thing telling us how many of the lights are turned on. Just like that. We can do the same again by just saying $: all lights on. And to do that, we're basically just going to say light on count is equal to 2. So here you can see that actually we're using a $: syntax, but one of the thing that we depend on this line is another reactive statement. So what happens here is, well, let's show it on the screen first, and then we'll walk through kind of what's happening in this dependency graph that I mentioned earlier. To start off with, it's false. All the lights aren't on. That makes sense. Turn that one off. Still false. Turn that one on. Now it's true. And what's happening when we click on that second light to turn it on is in the light component, it runs this on click. That runs toggle, which updates the light on value here. Svelte knows that light on has updated, and it knows that the second value in lights on depends on that light on value that just got updated. So it updates lights on as well. It sees that lights on is updated, and it knows that the light on count depends on lights on. so it recomputes this. It sees that this has changed, and it knows that this depends on that, so it recomputes this. Now it knows that all lights on is equal to true. It must have equals there. JavaScript, isn't it? It sees that all lights on is now true, and that's changed. It then knows that this bit of the page depends on the value of all lights on, so it surgically updates that bit of the DOM. That seems like a lot of work, and it is, but the big bit that you need to take home from this is that actually nothing except those things changed. Only those bits actually got updated. All the rest of the page didn't have to re-render. We didn't have to worry about any other changes that could have happened. Only the exact bits that could have changed were actually recomputed. And what's more, it knew at compile time what relied on what. It knew that dependency graph. So at runtime, it just ran through it. It's just hard-coded in the JavaScript to tell it what to check and what to recompute, rather than us having to check it every time something changed. Let's do something fun with this all lights on, and we can show off a couple of the more exciting functions of Svelte. A big one is the if statement. You can put any Boolean statement in there if you want. It doesn't just have to be a single variable. But if all the lights are on, then I want my angry dad to say, oh, it's like the bloomin' Blackpool illuminations in here. Blackpool illuminations in here. My dad never said that, and nor does he sound anything like that. So I'm not sure where I've got that from, but there we go. When all the lights are on, we get that message showing up. And if we look in the DOM here, you can see that it's actually adding and removing that node when we click this. And it's doing that surgically. It's grabbing that node and then removing it from the DOM and then adding it back in, rather than re-rendering the whole page or doing anything huge like that. The next big thing that I see as a possible improvement with this is making it easier to add more lights. Because, yeah, it's easy enough to just kind of add a comma and put some more in here and add another light down here, but it would be better if there was a user way to do it. So let's add a function which adds to that list of lights. So add light. And what I wanted to say is lights on is going to be equal to, we'll spread lights on, and then the final element is going to be false by default. So when we call that, it's going to update lights on, it's going to add another element on the end. The next thing I see is that this is fine, but the all lights on, this now needs to be equal to the current length of lights on, so lights on.length. And that should work. The only other thing is that this bit's now going to be broken. So we're only ever going to show two lights and they're hard-coded given positions. So instead of doing that, let's use another bit of that Svelte syntax. We're just going to say, not every, each. So for each element in lights on, as light on, do this. So lights on is the array up here, and light on will be the first or the second element of that. In there, we can put our light component bit of syntax there, and then we bind the light on variable in here to the light on variable in our array. And so because this is in an each syntax, it knows that when we're saying bind it to this value, we're actually saying bind it to the relevant element in the array. And it just abstracts away from that. So we can just create a light for each element in the array. And you can see there, we've now got two of these, those are working. And if we added some more lights like that, it'll re-render and add another one. Let's add a way for people to actually add a new light. It's just going to be a button. On click is going to say add light. And we're going to give it the text add light. There we go, now got a button. And when we click it, more lights get added. Like that. Cool, so we've seen Svelte in action and we've seen how you can write a very simple app, which is, again, fairly complex under the hood, but without having to worry about any of that complexity. Well, four of the biggest features for me are stores, await, transitions, and tweening. I'm just going to talk a little bit about what those are and what they bring to Svelte. Stores are a way for you to do like global state in the same way that you have a Redux store in React Redux. They're essentially giving you the same functionality as that reactive declaration syntax, the $: syntax, but you can use it anywhere, just in plain JavaScript files. So you can define a writable store, which then your Svelte components can subscribe to the store and essentially update whenever that store's value changes. You can then go a step further and have derived stores, which are stores based on other stores, so that when the underlying store changes, they recalculate their state and update the page if they've changed. That lets you build up a really complex state system, but all of your components remain very simple. They just hook into the bit of derived state, almost like calculated columns in SQL. They hook into that bit of derived state that they actually care about. The second one there, await, is in the same way that we had that if syntax and the each syntax. Svelte also gives you an await, where you essentially can say, await this asynchronous function. While we're waiting for it, display this on the page. When it returns, display this on the page, and you can pass in, you can like take the result of the promise as an argument to that little block. So you can then display the results on the page. And you can also have a catch, and you can say display this when there's an error, which just means that handling asynchronous function stuff like API calls is really simple. You can do it in one page, and your page just handles sending the request, dealing with it while it's pending, dealing with it when you get the results, and dealing with errors all in one go. The next one is transitions. Again, super simple. The same way that we'd specified like onClick and bind in our HTML elements, you can also just say like transition slide or transition scale, and that means that when that div is added to the page, it will like expand rather than just appearing, or blur, like unblur to exit. You can do a load of stuff like specifying the duration of the transition, different transitions for input and output, as in for when it's added and when it's removed. And you can do like delay, you can specify the easing functions, and you can even do your own transitions. The best bit about the transitions is that if you just use pure CSS, so if you specify your transitions in terms of changing the CSS, then they actually get compiled to like plain CSS transitions rather than any like complex JavaScript stuff. That means they're super fast. And you can use JavaScript if you want to, if your transition can't just be done with CSS. The last one there is tweening, which is similar to transitions, but essentially it's a way for you to say, this component should display this value, but when I change the value, I don't want it to just change immediately. I want it to gradually change over a set duration using a set easing function. Stuff like when we turned our lights on, in a previous version of this talk, I did actually code this, but when we turn the lights on, rather than just going grey to yellow, they should slowly fade, and we can do that by like tweening the lightness in a HSL colour. All of those are really great features, and they're all stuff that kind of just hooks in really nicely with Svelte and gives you an easy way to do all of the things that you do commonly in web development. And I wish I could have shown you them, but there just wasn't enough time. So, in conclusion, Svelte is simple. It abstracts away from state management and lets you just define the relationships between the variables instead. It does all that hard work at compile time on your development hardware, which is probably far faster than your end user's 10-year-old iPhone they're running the site on. It works more like a language than a framework, meaning that you get minimal boilerplate. It provides a very thin layer of kind of state management, reactivity, and then some helper, almost utility functions for dealing with HTML. And yeah, like I said, it feels more like an extension to JavaScript than it does a framework or a library. You should use Svelte in your next project. And I think you should try this. Maybe not a big work project, but a small personal project, definitely. It's kind of production ready. It's growing fast, and it's getting a lot more popular. It's stable, it's feature rich, but it's got a small ecosystem, and there are occasional rough edges. The rough edges do get fixed constantly, and there's very active development going on. One of the things that I ran into recently was the date input. So like an HTML input type equals date comes through as a string, and there's not an easy way immediately to convert that to a date. But they're looking at adding that, as in like there were discussions 4 or 5 days ago on the Svelte issue tracker. It does support TypeScript. I've got a blog post about that. You can have a look at that on the Scott Logic blog. Just scroll down a little bit. It's quite recent. And yeah, it's really easy to learn. In the course of this talk, you have learned enough to write your next application in Svelte. That's all that I have for today. I hope that you've enjoyed it. I hope that you've learned something, and I hope that next time you come to write a project, especially just a website, a small personal site, yeah, think about Svelte, because it might just be the future. Thank you very much. I've been Stephen Waterman. I will be doing questions straight after this talk, so come along, ask anything, and I'll see you around. Thank you very much. Goodbye.